Week two, there was only one class, but there's still a lot to talk about. So, generally speaking, today I'm gonna go over just Stag again, like how you know what to go where, and then kind of expand on what was done in class to show the power of Stag architecture. So, kind of first of all, just wanted to review Stag itself. Generally speaking, Stag separates stuff into three kind of core sectors, either a scene, game object, and component. Scenes are scenes just are a list of game objects. Game objects are a list of components. Components then do your start to actually do the start, update, and draw aspects of your game. So in the end, every scene is just a bunch of components. Um, but the way we organize it makes it super easy and expandable to use. And the way we do this is we just set our current scene and then we just say, hey, let's start it. So in this case, when we start it, we go through all of our game objects. When we start all those game objects, then we start those components, and then we do whatever is needed or whatever is in the components for start. Kind of, and this goes for the same for update and draw as well. And then we just do the game loop so that we always do that consistently. Um, but obviously this is a very simple game right now. So if we look at, for example, this, not collisions.js, but if we look at this where I did my dungeon crawler game that I talked about in class. Is this? Yeah. When we look at it, we have a little bit more in our engine, but the same core idea of seeing game object component, where for when we start, if basically it's saying if it hasn't started yet, you start the scene, and then you go start all the game objects for update. You go through all your updates, and then you update our game objects, and you update them. And same for draw. It's just a little bit more complicated, but forecast game objects of this just layer. If it's you game object dot draw. So generally speaking, even these more advanced games, this engines, generally speaking, in future down the line, like in down the line, we are still doing start, update, and draw type of stuff. Same with game objects. We have your start, draw, and update stuff where it's pretty much the exact same of what we have. And then same for components as well, where a little bit different. It's a little bit different architecture from what we're going to do in class, but generally speaking, it's the same thing. Um, and then you can also have, and then let's look at this one where we look at classes and we look at scenes. You have update draw, and then components. Like all these kind of have the same core idea of start, update, draw, or something of the sort. That's kind of the whole overview of Stag architecture. And we can kind of further this by looking at some of the slides where, just generally speaking, it kind of shows the overall hierarchy where a game engine has a list of scenes, which has a list of game objects, which has a list of components. And the way we separate it is we usually have like parent classes of scenes, game objects, components, and then we usually do have game engine components. For example, one very common one is the position, or many call it the transform of the game object, which is just the location. And then you have your game classes at the bottom. And this kind of just shows the hierarchy where scenes are the highest, and they kind of do everything regarding your big picture. So if there is any major change to what you're doing, for example, going from the start screen to the gameplay screen or a transition screen between levels, you want to change scenes. Game objects are just one step lower, where they are more just things in the game inside of the scene. So one thing that's kind of weird, or not weird, but and unintuitive, is that there's a lot of invisible game objects. So obviously there's a game object for like the score, the world, the player, but there's stuff like controller, hitboxes, and like back-end generation stuff that isn't really displayed on the screen. So with my dungeon crawler, for example, the layout of the floors, that's an invisible game control or a visible game object that may not be very present. But the most popular times you see this are with like controllers, and where like for input, movement, stuff like that, um, and then hitboxes. And then the final one is components, where it's just the building blocks of the game objects. And usually these are allowed to be reusable, which will be demonstrated today, where we can kind of show you how to reuse a lot of the some of the game objects we have in class. And then there are some universal components, which the key one is the transform, like stated earlier, where it is the position, um, and the scale of the object, of the game object. So overall, this is kind of the hierarchy, where we have the title scene, and then we have your game objects, and each one has a transform. Um, yeah, so that's kind of the core big picture. And eventually, once we get fully in depth with Stag, um, we will have each game object will kind of have a little bit more logic to it. So like there's also static methods, which you kind of saw inside of when I was going through some of the previous game engines that this course has created, where like there's like a destroy, which would remove the game object, get object by name, kind of stuff like that. And that will be further explored down the line. Kind of just wanted to go over engine versus console code again with some of the more advanced ones, so you kind of get a better picture. So there's kind of some general things that are kind of used everywhere. For example, circle. I mean, there are many games, especially specifically in this class, where there is a circle, or a circle-like object. So for example, you want to create an octagon or a triangle or a rectangle. I mean, typing out this code is nice, but it gets repetitive, and we could easily simplify this by just having a circle or triangle or rectangle component inside of the engine, and then we just tell its position. Um, Text. Generally speaking, text is really always the same. There's just different fonts and fill styles. So all you need to do is just pass that, and then you can pass it into like a text component, and then just change it through. For example, in the constructor you could have like a fill style variable, a font variable, and then a text variable, and then it'll just allow you to very easily create text. And then transforms the big one, that is usually in the engine, where it is just your X and Y position for the scope. And then this is kind of what we did for this specific engine. So, and obviously you could go more in depth. There is, like if you look at components, there's like lines, points, physics-based stuff is usually in the engine, because every game doesn't has some sort of physics at a varying degree. It just might not be a physics-based game, but there's still so many physics. If with collision and collision resolution and stuff like that, that usually physics and the core ideas of physics are in the engine, but maybe what happens if there is a collision is in the game. Um, so I kind of want to expand on what we've done in class today as well to kind of show you the power of static architecture and kind of um, expand it a little bit more. The first thing that I'm going to do is I'm going to expand the canvas. So if you type in canvas.width, which in this case, if we comment this out, what I'm first initially going to do, because I don't just like this little, what I'm going to do is I'm going to set the canvas width to be the height of the window, basically. So if you just do canvas.width equals window.inner width minus 10, and then canvas.height equals window.inner height minus 10. And when you look at that, and now it just expanded the canvas, and we still bounce off because I referenced the canvas dot in the game. If we specifically look at our triangle controller, I reference the canvas width and height, which is what we're setting in here. So let's change that to minus 20 just to make it a little bit more even across the board. So now we have a bigger window to play on so that we can kind of expand on it a little bit more. Let's first do this. So let's say I wanted to add another triangle game object. I could do this dot game objects dot push new triangle game object. And when we go over, you'll first see that, oh, okay, there is only one triangle still. Let's try and debug this. So if we go to the triangle controller, I added a constructor just to, let's do this. So in the constructor, let's do a console.log to show when we look at it now and we look at the console. Oh, we have created a triangle and has that 2 by it. So that means that it was printed twice. Let me also remove that as well because we don't need that. So what's happening? Well, what's currently happening is that the triangle controller is statically defined to be this dot vertex x, which is defined in the this vector 2 in the start. So one way we could do this is we could bring data downwards. So now inside of the triangle game object, or let's do the triangle controller, we could do this where we have a x position and a y position. We could say this dot x position equals x position. This dot y position equals y position. And now what we can do is we can do this vertex vector to be this dot x position and this dot y position. Now inside of our triangle game object, when we do the controller, we would need x position, y position, and then in the constructor, we would also pass that down. This is a temporary fix. Later on, there will be a much cleaner way to do this when we include transforms. But now in here, say I wanted to do 100, 500, let's do 100, 100, and then 250, 250. Let's see if this works. Yep, so now you see that it's offsetted and everything still works. So we still bounce off the walls, we still do all that sort of logic. But what if I just don't want triangles? What if I also want to do rectangles? Well, we could, Another thing I would highly recommend is you create folders inside of your game, which do scene, um, game objects, and components. Because it gets messy if you don't do it. So when we drag these in, we will also need to update this. So it would be that slash game slash scene slash um, main scene. Uh, then it would be, is this game object slash triangle game object? And it would be game component slash triangle component. Let's just make sure everything still runs. Nope. Okay, let's see what the issue is. It does not reference main scene, which means that we have done. Oh, it's not main scene.js. Okay, now everything's back and running again. So say let's now do a rectangle game object. So let's do a new file. Let's do rectangle game object.js. Class rectangle game object extends game object. We have a constructor. And let's follow the same kind of logic. Be careful with copying and pasting code because a lot of the time, not a lot of the time, but you can have copy and paste errors. So like, for example, this is triangle controller. So if we wanted to change that, we could say rectangle controller, and could create that. Like this is create a triangle, so it should be create a rectangle. But let's now duplicate. Let's now copy and paste. And if we rename this to rectangle controller.js, we have your triangle, your component, constructor, start, update. So the main thing we would need to do is we would need to do a ctx.line2, and then it would be 100 plus this dot vertex dot x, and then 75 plus this dot vertex dot y. That should be a rectangle. And now we have a rectangle controller. So you see, I was about to do that, but there's a copy and paste issue there, so that would have been an issue. But now if we go back to our rectangle game object and add rectangle controller, and then inside of our main scene, we would need to add. I even do one more than Rick's generally. I like to split into scene game objects and controllers and components inside of here. So this is what I will do, and then I will do rectangle and rectangle. And now inside of our scene, not scene.js, inside of our main scene, what we can do now is we could do this dot game objects dot push new rectangle game object, and let's do position 275, 100. Okay, let's look at what this error is. It says X position is not defined. So if we go into the rectangle game object, yes, yep, so I forgot to put the X position and Y position in there, which means that there's no X position or Y position to begin with. And if we reload, okay, so it's not a rectangle, but we could say it's close enough. And it still works, collisions, all that still works, but honestly, it's still kind of monotone in the sense that it's still pretty slow. Nothing, all of them are kind of sticking together. Nothing really too crazy's happening. So let's now upgrade this even more. In the game objects, let's add a speed. Let's add a speed X and a speed Y. And again, a lot of this stuff is temporary because we're still kind of exploring the full capabilities of Stack, but this kind of shows you the reusability of game objects and components. Now in our controller, now we also have a X speed and a Y speed. And now we just do this dot X speed equals X speed, this dot Y speed equals Y speed. And now instead of doing this, we could do this dot X speed, this dot Y speed. So now that we have that, we have now it being based off of X speed and Y speed. So now let's do that for this as well. We could just copy and paste this. And again, be careful with copying and pasting because there are so many times that I have gotten errors with just basic copy and paste issues. So always be mindful. But now that we have this, if we go back to our main scene, and now let's make this triangle go this, let's make this triangle go that, and let's do 5, 5. See, so now we have a little bit more movement, different ways of moving, stuff like that. And now you can really easily expand because now if you wanted to create a triangle that moves this way, all you would have to do is copy and paste this triangle. And let's say we wanted to start at 500, 500. All you have to move is -1 in the X and +1 in the Y. And now you have, oh, apologies, I forgot that it is -1. And now you have a triangle that goes upwards in this corner. Rather than rewriting all this other code all you have to do is now add that game object again, and now you're good. So this is kind of really the power of this type of game engine, and it allows you to really create big, expansive games that primarily reuse code rather than having to rewrite code. I think that's pretty much it. So again, I think next week we'll probably start developing more of an actual game that's more interactable, stuff like that, which will be good. And if you have any questions, concerns, my email is always open. You should be able to see that at the syllabus.